Principles of the lag screw and the position screw. In these exercises, you will apply a screw with a lag function and another with a position function. The instruments to be used are the brown 2.5 mm and the 3.5 mm drill bit, the 3.5 2.5 double drill sleeve, the brown 3.5 mm tap with T-handle, the countersink, the depth gauge, and the screwdriver with holding sleeve. Exercise A. A lag screw will be placed in the bone model perpendicular to the fracture line. Be sure to choose the end of the bone that has a simulated fracture matching the one shown on the screen. The 3.5 mm drill bit is placed through the appropriate end of the double drill sleeve. The glide hole is drilled through the near cortex only. This hole has the same diameter as the outer diameter of the threads of the 3.5 mm screw. The 2.5 mm end of the double drill sleeve is placed through the glide hole until it engages the far cortex. The 2.5 mm drill bit is passed through this end of the double drill sleeve, and the thread hole is created in the far cortex. Remove the double drill sleeve. Attach the countersink to the T-handle. Countersink the glide hole in a clockwise direction. Using this instrument increases the contact interface between the bone and the screw head. The depth gauge has a rod with a hooked end and a measurement bar, which is used to determine the length of the screw needed. The measurement bar is marked in 2 mm increments. The hooked rod is passed through both holes in the bone. It is tilted slightly and withdrawn until the hook engages the surface of the far cortex. The rounded end of the measuring device is pushed tightly against the near cortex, and the length of the screw is determined from the measuring scale. Measurements are rounded up to the nearest 2 mm mark. The 3.5 mm tap is placed through the appropriate end of the double drill sleeve and passed through the glide hole until it engages the thread hole. Turning the tap cuts the thread in the thread hole. The tap should be turned until at least 2 or 3 threads have exited the far cortex. The tap is removed. A 3.5 mm cortex screw of appropriate length is inserted. Compression is achieved across the fracture line as the screw is tightened. Note that the long axis of the screw is perpendicular to the long axis of the fracture line. The screw is removed and the bone model rotated 90 degrees. A lag screw is inserted as before, with the only exception being the orientation of the lag screw relative to the fracture line. When the lag screw is not placed perpendicular to the fracture line, shear forces develop along the fracture line. They can cause displacement of the fracture fragments, as is shown in this demonstration. Exercise B, the position screw. If the configuration of the fracture is such that the fracture fragment will collapse into the medullary canal when compression is applied, then a screw with a position function should be used. A thread hole is drilled through both the near and far cortices using the 2.5 mm drill bit through the appropriate end of the double drill sleeve. In the bone model, it will be necessary to support the fracture fragment while drilling. The length of the screw is determined by using the depth gauge. Note that the countersink was not used. The 3.5 mm tap is used to cut the threads in both the far and the near cortices. Now the appropriate 3.5 millimeter Cortex screw is inserted. The position of the near fragment is maintained by the screw, and the fragment can no longer be collapsed into the medullary canal. Remove the screw. The effect of using a screw with a lag function in this type of fracture configuration will be demonstrated by creating a glide hole in the near cortex with the 3.5 millimeter drill bit. The same 3.5 millimeter screw is now reinserted. Because the threads no longer engage the near cortex, the fracture fragment collapses into the medullary canal as the screw is tightened. Exercise C. An oblique screw through a tubular bone. Occasionally, an oblique screw has to be inserted through a bone with a marrow cavity. The glide hole is created with the 3.5 millimeter drill bit through the 3.5 millimeter drill guide in an oblique direction through the near cortex. The 2.5 millimeter drill guide is introduced into the glide hole in the brown 2.5 millimeter drill bit inserted. After entering the medullary